Number 1, we're going to name these compounds and indicate which has a higher boiling point. We're also going to explain why. Now, this language was taken directly from the quiz pool, and it says only answer in the text box. No work on the file upload will be viewed for a grade. So I wanted to point that out specifically to get you aware of what is expected for the quiz. Now, we need to name these compounds. So both of these compounds have nitrogens on them. And the first one looks like this. Now for IUPAC naming, we need to find our longest carbon chain that contains our functional group. And here we have a propane. Now our functional group is this nitrogen. And this nitrogen is going to change that ending from propane to propanamine. And that is on carbon 1, so 1-propanamine. But then I have these substituents. So I would indicate that they are on the nitrogen by putting an N. So this is N1,2,3-propyl and methyl. So N-methyl, N-propyl, 1-propanamine. Now this second compound here looks similar, but the methyl group is over here on the second carbon of my propane. So let's name this. This is going to be 1-propanamine, just like the other one. But we have a 2-methyl, and we have an N-propyl. Now I would probably rearrange this. This would be 2-methyl N-propyl, 1-propanamine. I think that would be the better way to do it since that is alphabetical order. So 2-methyl N-propyl, 1-propanamine. Now, which is going to have the highest boiling point? They both have the same molecular mass, but one of them will engage in hydrogen bonding, and that is this one. This one will have hydrogen bonding. This one will not. This one is actually, well, he does have a lone pair of electrons here, so I guess he is polar, but he does not engage in hydrogen bonding. This one does. There is a hydrogen that is covalently bonded to a nitrogen. Therefore, 2-ethyl N-propyl, 1-propanamine will have the higher boiling point because it engages in hydrogen bonding. Now let's put these in order from the least to most acidic. What we're looking at here, we're going to look at the hydrogen bonded to the oxygen, hydrogen bonded to nitrogen, and hydrogen bonded to carbon. So the least acidic is going to be the one that just has carbons, ethane. The mid-range is going to be the ammonia, and the most acidic is going to be methanol. Number 3. Now, this problem, number 3, is an example of a problem that you have on your quiz, but each one is worth 15 points. So really spend some time with these questions. So first, you're going to look at this reaction or reaction step, and I want you to name the organic reactant on the left. And what that means on the left is this first one here, and that is 2-butanone. Name the final product. On some of these examples, there will be more than one step. So I specifically want the final product, which in this case, we have a 2-methyl butane, but we have that oxygen there. So how do we name that? Now, I picked this one on purpose, so couldn't remember if we had named compounds like this. When you have that oxygen there, and it is a negatively charged oxygen, all of a sudden that becomes an oxide. So this is 2-methyl butoxide. Now, what would the final product be soluble in water using solubility trends? Well, now we have this oxygen here. It is negatively charged. That means it's an ion. There are 5 carbons. So by our rule of 5, yes, this should be soluble in water. Now we're going to draw the mechanism steps on our paper. We're going to show electron movement with arrows. So first I need to draw out my reactants. And let's see, that is CH3 with a negative charge. So that means that there are electrons there. And I know that that is going to make this compound. So how do we show the electrons? Well, I need to locate that electrophile. I need to, and that's number 5, we need to indicate the electrophile and the nucleophile or the base. In this case, we do have a nucleophile. We are making a new bond. So we do have a nucleophile, a new carbon bond. So here we have our nucleophile. And then this is our electrophile. And I know that it is the electrophile because that is where the new bond is made. You see, we have this carbon here that used to be our sp2 hybridized carbon, our carbonyl carbon. Now it is sp3 hybridized. And the way that works, I'm actually going to use green for my electron arrows. I'm going to come down here. That's going to break the pi bond, push the electrons up. So we can show one bond being made and one bond being broken. And that's all that you need to do. You identify that electrophile, you identify that nucleophile or base, if that's what's happening, and show the electron movement. Now, when you go to upload that file for your homework, I want you to use the Embed Image button here. Click Canvas, My Files, Upload File, navigate to your picture, and upload your file. And you'll embed it right here. Now also keep in mind that there could be some solubility prediction questions as well as a challenge mechanism. And I want to call attention to this challenge mechanism. It looks difficult, but it's really the same small steps. So don't be overwhelmed by it. Just take it in pieces. Find your electrophile and find your nucleophile.